Friends, now we are solving the differential equation x square y2 plus xy1 minus 4y is equal to 0. If you observe this, y1, y2 is nothing but the first order derivative and second order derivative. This one we can write in a operator form. If you written in operator form, then we will have x square into d square plus xd minus 4 into y is equal to 0. Y you can take common, where d is equal to d by dx. But friends, here you observe, this is the derivative is containing the quotient is what? X. Term is x here. So for d square, quotient is x square, d quotient is x. So by the observation, what we can say here, the index of the x and the order of the derivative is same. So you can say this is a differential equation. This differential equation is said to be Euler Cauchy equation. The differential equation is said to be Euler Cauchy equation. Generally the differential equations are two types. One is a constant quotient, another one is variable quotient. So here you have a variable quotient. So in this case what we have to do means, we cannot solve this problem directly. For this we have to convert into constant quotients. How you can convert this one, the given problem, into constant quotient means there will be some steps are there. Okay, in the first step what we have to do means, we have to put in the first step we have to put x is equal to e to the power of z. Next, here d is nothing but d by dx. X is equal to, we are substituting e to the power of z, then z is equal to, you will have a log x, where d is d by dx. We are converting this xd into theta, where theta is denoting with d by dz. Nothing but we are differentiating with respect to z. Theta is nothing but differentiation with respect to z. Now in the problem we have x terms and xd terms. Okay, xd term is there, x square d square is there. So if xd we will replace it by theta, and x square d square we will replace with theta into theta minus 1. Then this constant, this variable quotient will be become as constant quotient. That is, you will have finally f of theta into y is equal to q of z. Now this is a f of d into y is equal to q of x form only. So in this case you will have the solution is complementary function plus particular integral. Complementary function plus particular integral. After finding the complementary function particular integral, you will get the function is in terms of z. Later we have to replace z is equal to log x. Then you will get the final solution y of x as a complementary function plus particular integral. Okay, this is the procedure to solve this differential equation. Now the given differential equation, what we have, x square d square plus xd minus 4 into y is equal to 0. Now what I have to consider here in the first step, let x is equal to e to the power of z. That implies z is equal to log x. Now xd also I am writing as theta, where theta is nothing but d by dz. Next, x square d square you can write as theta into theta minus 1. Theta into theta minus 1. Now substitute these all values in the above equation. Then we will have theta into theta minus 1 plus theta minus 4 into y is equal to 0. Now this is theta square minus theta plus theta minus 4 into y is equal to 0. So minus theta plus theta getting cancelled. Then we will have t square minus 4 into y is equal to 0. By the observation we can say this is in the form of f of theta into y is equal to q of z form. Q of z form, where q of z is 0. What is the general solution for f of theta into y is equal to q of x? You see, now we are in second step. That is, y of z is equal to complementary function plus particular integral. But here you see q of x is here 0. So directly you can get the particular integral will be 0. So you will have only y of z is equal to complementary function. How we can find out the complementary function? You see, the complementary function for f of theta into y is equal to q of z, what we have to consider means, let y is equal to e to the power of mz, e to the power of mz be a solution of f of theta into y is equal to 0. Then we will have the auxiliary equation. That auxiliary equation is f of m is equal to 0. So here you observe, if I replace d to the power of mz, what will happen? You see, theta square minus 4 into e to the power of mz is equal to 0 we are considering. Now e to the power of mz one time if you are differentiated, then you will have m into e to the power of mz, but theta square is there, so we have to differentiate with respect to z twice. So again if you differentiate it, you will have again m into e to the power of mz. So m into m square minus 4 into e to the power of mz is equal to 0. From this you can take e to the power of mz is a common. If you take an e power mz common, m square minus 4 is equal to 0. So in this case product of two functions are equal to 0 means any one of them 0 or both will be 0. So here e power mz is never 0. So only m square minus 4 is equal to 0. So that m square minus 4 is called auxiliary equation. We are denoting with the f of m is equal to 0. Now you solve the roots for the f of m is equal to 0, then m square is equal to 4, m is equal to plus or minus 2. Here the roots are real and distinct, okay, or else different. In this case the complementary function we are denoting with y of z, because f of theta into y is equal to q of z form. This is theta is nothing but differentiation with respect to z, not x. Now c1 e to the power of 2z plus c2 e to the power of minus 2z. Friends, you see what you have, x is equal to e to the power of z, then x square is equal to e to the power of 2z, x power minus 2 is e to the power of minus 2z. So you will have y of z is equal to c1 x square plus c2 x to the power of minus 2. This is y of z value. So what is the final solution we have actually for f of theta into y is equal to 0? Y is in terms of what? X only. Now is it in terms of x or not? You see, this is, you can say x terms, this is a function of x, so I have written here y of x. What is the final solution? Y of x is equal to complementary function plus particular integral. What is the complementary function you have? c1 x square plus c2 x power minus 2. What is the particular integral? That is 0, because right side part we have 0, that is why particular integral will be 0. You see, particular integral we will write as 1 by f of theta into q of z. So 1 by f of theta into q of z is 0. So what you will get the answer directly? 0. So this is the final solution. Is it clear for everyone how to solve this problem? Step 1, you see, first we have to consider x is equal to e to the power of z and z is equal to log x, and we have to write xd is equal to theta, x square d square is equal to theta into theta minus 1, and x cube d cube is there, suppose theta into theta minus 1 into theta minus 2. Now we have to substitute these all values in the given problem, then you will get in the form of f of theta into y is equal to q of z. You see, f of theta into y is equal to q of z form. Now we are in second step. Then the solution is, general solution is complementary function plus particular integral. If q of z is 0, then you will have only complementary function. So we have to find out the complementary function. Y is equal to e to the power of mz be a solution of f of theta into y is equal to 0 if you consider, then f of m is equal to 0 is the auxiliary equation. Then you have to find out the roots for the given differential equation. After finding the roots, you will write the complementary function. Whenever the roots are real and distinct, suppose a comma b are the roots, then what you will write generally? c1 e power az plus c2 e to the power of bz we will write. That's it. So here you see 2 comma minus 2 is there. So c1 e power 2z plus c2 e to the power of minus 2z I have written. Is it clear for everyone? Right? Thank you for watching this video.